Orv is W6BI. He was first licensed in 1967, so he's got me beat. I was licensed in 82. And he's been into digital ham radio all his life, starting with CW. And few people remember that CW is a digital format. He worked his way up through RTTY, Pactor, Packet Radio, PSK31, and he started messing around with ham radio networking in 2014. He's given this presentation, or this reasonable facsimile of this presentation, over 30 times regarding using AREDN, which stands for Amateur Radio Emergency Data Network Software, to create a ham radio network. So I'll just like to say one more thing, that he's also active in coordinating the ongoing build out and maintenance of the wider Southern California ham radio network, which spans from north of Santa Barbara down to the Mexican border and east to Las Vegas, comprising over 400 nodes, both on hilltop and ground level, including some hospitals. So, Orv, it's a pleasure to have you join the Santa Clarita Amateur Radio Club. This is Orv W6BI.
Yay.
Thank you, Orv. Appreciate it.
Orv.
Thanks, guys. Let me, may I share my screen?
Yes.
But before I do that, let me turn off my video so it's not distracting. I seem to recall, and I recalled, and I in fact looked back, and I had given this presentation, or a reasonable facsimile thereof, to the Santa Clarita Club in early 2016. So it's been 5 years. Since then, a lot has happened. We'll catch you up and show you what's going on regionally and in your backyard. Anyway, I'm Orv W6BI. Been a ham radio operator since forever. And this is presentation number 37. So let's talk about speeds, not throughput, but modulation rates. Guys, if you could mute your microphones, I'd appreciate it. So anyway, Morse code isn't ASCII, but it was approximately 30 to 50 bits per second. RTTY is not ASCII either. It's baud, 5-level baud, 45 to 50 baud. Packet radio is 1200 baud, and for the modulation rates modulation schemes are using, 1 baud is 1 bit per second. So that's 1200 bits per second, or in modern terms, 0.0012 megabits per second. It wasn't especially fast then, and it's looking especially decrepit now. Pactor, the various versions of fastest, one of which is 4. Pactor 4 is about 5.2 kilobits per second. I read recently that's not legal in the US, for what that's worth. There's a new scheme called VARA. It's available on FM and HF, and it ranges between 5.8 kilobits per second and 20 kilobits per second, considerably better than Packet. The ham radio networking links that we put up can be more than 100 megabits per second. Now remember, that's not end-to-end throughput. Just like those of us who remember 56K dial-up modems, you didn't get 56K end-to-end. That was the modulation rate between you and the modem on the other end. So ham radio networking uses stock wireless access points. There's not a lot of hardware hacking to be done anymore, which is a good thing. The AREDN software supports 4 different brands: Ubiquiti, TPLink, MikroTik, and GL.iNet. And they have a wide variety of products we can use. We take these access points and load up the AREDN software, and it makes them ham radios. And we'll talk more about that in a bit. Once they're up and running and they hear other nodes, which is what we call them, they form a TCP/IP network, just like the internet. Slower and not as widespread, but it's the same principles. So anyway, about the software as of today, it was derived from OpenWRT, open source router software. Back in the day, late 90s, Linux was really, really hot and it was the in thing. And Linksys said, well, you know, here's this operating system. Let's take it and tweak it. And they did, and they put it in all their Linksys products. Well, a while later, the open source community said, we can do better than that. And since it's open source and available to anyone, they started rolling their own router softwares for your home modems. OpenWRT is one of them. DDWRT is another one. There's one called Tomato and a whole bunch of them. They support a wide range of home wireless access points or routers. And just a side note, if you've got an older um, home modem that's not supported anymore by the vendor, you might think seriously about loading some of this third-party software on it because they maintain it. It's highly secure. They patch for enhancements and bugs and security issues. Recommended. Anyway, the AREDN software supports, like I said, 4 different brands of equipment, and it's now over 70 different models. They just added another brand and model. I don't even have it in here yet. And that's across 4 ham radio bands, and we'll talk about that in a minute. And if you happen to be in an RF desert where you don't have a radio link to the nearest hilltop node, you can tunnel between nodes and join the network that way. These next 3 bullets are bolded because they form the core of ham radio networking. You may not know it, but adjacent to the 2.4 and 5.8 gigahertz wireless bands, the Part 15 bands, there are Part 97 ham radio only channels. And AREDN has learned how to move the gear down into those channels, which, as you would expect, are much, much quieter, and we get much better performance from them. The software also supports MIMO, which is multiple input, multiple output. And we'll talk about that a little bit more. And you may have heard of 802.11a, b, and g. Well, 802.11n is a newer generation. It's not the newest anymore, but it's ideally suited for the long haul network links we use. Additionally, the software provides domain name services, DHCP services, which is your IP address server, route discovery, and routing information. What that means is you don't have to worry about defining routes. The nodes find each other. And all those 3 put together makes it relatively easy to get these networks up and running. So let's talk about the wireless access points, which are known as nodes. You have to consider them like handy talkies. They're low power, less than a watt, and they are strictly line of sight, strictly. So just like a handy talkie, you normally talk through a hilltop radio site or a mountaintop or water tank or something. And because of the routing algorithms, if your node hears multiple hilltops, it'll always choose the best one because it can figure out the best route. So there's no point in using an omnidirectional antenna. Use a gain antenna of some sort. And I found this a long time ago. Microwaves can go through, used to be 15, now it's 25 miles, or 1 tree. Or as we say, two's company, tree's a crowd. So let's talk about the bands. 900 megs, 2.4 gigs, 3 gigs, and 5.8. I'm not going to talk a lot about 900 megs. We only have one 5 megahertz wide channel, and we're co-located with every noisy smart gas meter, electrical meter in the world. Additionally, the gear is relatively expensive. You can do better on 5 gigahertz now. I'll talk about these other 3 bands in more detail later. So you've put up all these nodes, they've formed a network, and it looks great, but it doesn't do anything. It's just a network. All you do is use it to get to things like services. Here's a few examples of the things you can use on any network, including the ham radio network. And all of these here, subject and anything else you can think of that meets the Part 97 regulations. So here's a few examples. Locally here in Southern California, the group has tried all of these. We're not currently using all of these. By we, I mean my local group. Elsewhere in Southern California, they are using some of them. So anyway, a communications hub. If you've ever used Slack at work or at home, Mattermost and Rocket Chat are open source Slack lookalikes. They provide text and pictures and multiple channels. And all of them have, you can get to them through the server via a web browser, or they have apps for Mac, iOS, Windows, and Android. So I took this screenshot a couple years ago. This is our Mattermost server on the ham network. KG6WXC and his family were out camping in the desert near Ridgecrest when the 7.1 earthquake hit. They were on the flat, so they weren't harmed, but they got jiggled around quite a bit. And the next day, Eric drove over and took a picture of the surface rupture. And our ham radio network doesn't reach out there, but there was wireless, Part 15 wireless access out there. And because we have two Mattermost servers, one on the ham net and one on the internet, linked together, he was able to take the picture with his Android phone, post it in our Mattermost channel, and we were able to see it on this Mattermost server locally here on the ham radio network. So it's pretty cool. Voice over IP, everybody knows VoIP. This picture was taken, oh gosh, 4 or 5 years ago before we deployed it. On the left is an old Cisco phone. On the right is a Grandstream VoIP PBX telephone switch. At the time we were getting ready to deploy it, the guy who was pushing out the VoIP wasn't real comfortable with open source solutions like Asterisk. So he elected to buy this turnkey switch, and it served us very well. Here's a picture of it in the repeater rack. This is up on top of Sulphur Mountain, just south of Ojai. You can see there in the red circle. We're currently serving about 30 extensions. Most of them are at HAM's locations, but we have some in EOCs and hospitals, and county EMS has one too. So anyway, because we have a Grandstream PBX, could somebody mute their microphone, please? Thank you. Because we have a Grandstream PBX, we recommend that people, at least in this area, who get extensions off our Grandstream, get Grandstream phones, because we can manage them a little better and push out firmware updates. Anyway, you can see I have one missed call there, and the red light says I have a voicemail. It supports all the things you would expect from a PBX, call forwarding, conferencing, stuff like that. It's amazing how many times my phone rings. So this is the next PBX we pushed out. It's just a Raspberry Pi running FreePBX. This was put on Verdugo Peak, which is just north of Burbank, and the two PBXs are trunked together across the mesh network. We have, let me see, 1, 2, 3, 4, 5 or 6 PBXs in Southern California, and we'll eventually get them all trunked. Up there in the Santa Clarita Valley, K6BFG has one that he's experimenting with, and when he decides he wants to put it into production, we will trunk it together too. Collaboration servers are the kind of servers you may have seen the gamers use in movies or TV. Some of them are TeamSpeak, Mumble, TeamTalk. There's a whole list of them. And most of them provide voice and video chat, file sharing, desktop sharing. I'm sure there's other features. We chose TeamTalk. It's pretty much feature equivalent, but it's one of the few that doesn't encrypt data. So we had to avoid that whole encryption discussion. With TeamTalk, you can have many-to-many, chat rooms, or you can go one-on-one chats. And by the way, that's voice or data chats. You can set up as many channels as necessary, and I have a screenshot showing some of that. You can use your laptop speaker or microphone or a headset. With this, you can have multiple ongoing conversations in full duplex. That means you don't have to worry about talking to the guy who would normally time out simplex. You can interrupt him in his ramble and redirect the conversation. And I want to talk a little bit about this. The codecs will provide as much quality to the conversation as the network will afford. This is not your father's communications grade 300 to 3000 hertz channel. It's a pleasure to listen to. It supports push to talk. Mostly we use the left alt key on a Windows keyboard, but you can do whatever you want. Supports a Vox. We have a weekly net, and I will put my headset on, close the doors to the office, put it on a Vox, and put my feet up on the table and just have a normal conversation. And I would like to say that if you're talking to someone and the signal quality is good and you're both on headsets, it's like you're in the same room. It is a pleasure to listen to, especially for those of us whose hearing may not be quite as good as it used to be. It also has an open mic feature. This is where you nail up a connection between two laptops through the server and the voice channel is open. Don't use it in normal operations, but I could see if you had some sort of incident going and you had like a command center that needs to talk to an EOC nailed up, you put the laptops in a quiet room, link them together, and somebody would come in and say, hey, I need to talk to Bill. And somebody the other end says, hey, stand on, hang on, I'll go get him. And you might worry about bandwidth, but in looking at it, each voice conversation takes about 30 kilobits per second. And down here in Ventura County, our backbone across the county will support anywhere between 5 and 7 megabits per second end to end. So one nailed up voice connection is no big deal. So anyway, here's the Windows client. I took this screenshot from one of our nets. Oh, this was a few months ago. You can see everybody that's logged in on the left. When you talk, the background behind your call sign turns green. When you stop talking, it turns yellow. So you can tell who talked last. Down there on the bottom, you can see aux channel 1 and aux channel 2. If you wanted to talk to somebody privately, you both double click on the aux channel 1 or aux channel 2. You jump over there and you could have a private conversation. When you were done, you double click back up on the root where it says K6PVR at the top, and you'd rejoin the main channel. It's pretty slick. It also supports video. This is a screenshot of another net. Video doesn't add a lot to a net, honestly. It's fun to use. And what we do periodically is we have everybody fire up their cameras to stress test the network. Most of these clients you can see there are configured for either 640 by 480 or 320 by 240, which is fine for watching somebody. You certainly won't get high def across one of these things. And anywhere between, I don't know, 10 and 20 frames per second is fine. Each one of those streams there, I don't know, it's 100 kilobits, maybe 150. When we did this particular test, I watched the server and it was sitting at about 10% CPU utilization and about 10% bandwidth utilization. And the server's a Raspberry Pi 3, by the way. So they're a lot of fun. Anyway, the other thing you can use it for is video. I want to talk a little bit about the scenario about how this lapsed or came about. In 2016 and 2017, we were busily, or after the AREDN software gained the capability of different bands. Originally, it was just 2.4 gigs. But when it picked up 3 and 5, we started pushing out a backbone across Ventura County, linking repeater sites together. And this particular site, Sulphur Mountain, one of the guys had a junker camera, he threw it up, and we had fun looking at it. in the middle of late September of 2017, one of the other tech specialists in the Santa Barbara division sent me a link on how to stream web cameras to YouTube. He said, see if you can figure this out. Might use it someday in an emergency. So I had a test camera outside of my driveway looking at my cars, and I got it figured out. And I said, here, look, there's a YouTube stream of my driveway. Big deal. So I kind of put the notes away and forgot about it. And then December 2017, the Thomas Fire broke out near Santa Paula, California. Broke out a little after 6. Ben called me and said, hey, don't we have a camera up there? I said, yeah. He says, can you stream it? And I said, I'll see what I can do. Well, different brand of camera, different model camera, different OS, but I was able to get to it and get it set up in fairly good order. And we streamed this video out to YouTube for about 2 hours. That day, the wind was just howling, and an intermediate network point that didn't yet have backup power lost AC. But we were able to stream it for a couple of hours. And while it did, you could see it come over the hill and come closer and closer. That light at the middle there is the driveway gate of the owner of the private property this tower is on. And it after we lost video, the fire came down across his driveway and then went right to left about 100 yards in front of the tower, proceeded west and ravaged the town of Ventura. They lost hundreds and hundreds of homes. We learned some lessons from that. Better backup power, better cameras. We now have pan tilt zoom cameras everywhere that we can. And at this particular site, we had AC, battery, and solar panels. We lost the AC within about 4 or 5 hours. Batteries died after about 18 hours because the solar cells were covered with ash from the fire. So you do what you can. So that was in December of 2017. And the following year, we were busy doing upgrades. And this happened. The Woolsey Fire, November of 2018. Woolsey Canyon is off the screen to the left about, I don't know, 2 or 3 screens. It's right near the old Rocketdyne test facility. And again, it was dry, it was hot. Santa Susanas were howling. We actually saw the fire break out around noon, and noon on the 8th, I think. And anyway, it burned its way west to east through those hills. And this camera is a pan tilt zoom camera on the north edge of Simi Valley. And I streamed the video from this for about, I don't know, 36 hours. The other tech specialist, you may know him, he's been in the news lately, Ben, AI6YR, Ben Kuo. He was the guy who located that lost hiker a few weeks ago. In any case, he has a large Twitter following because he's very good about relaying communications about emergencies and incidents. And anyway, he posted the URL to the YouTube stream for this to his followers, and we had hundreds and hundreds of people watch this. After this screenshot, it came down and threatened the southwest corner of Simi Valley, and then turned south, went through Thousand Oaks and then through Malibu to the ocean and burned, I don't know, another hundreds and hundreds of houses and structures. June of 2019, Ventura County Board of Supervisors recognized ham radio month in June, like they do every year. But in the proclamation, they specifically mentioned this video. Excuse me, it was the proclamation in 2018 because they were referring to the Thomas Fire video. I forgot to mention that 3 or 4 days after that fire, I got an email from a Ventura County Fire Department fire inspector. He wanted the URL. I gave it to him. He thanked me, and presumably he looked at it. Didn't hear anything, but sometime later we heard through the grapevine that they found it useful because it was the first existent video of the fire. So streaming stuff out to YouTube is a good thing. So here's another one. this happened to be right down the hill from one of the sites, so I turned the camera around and watched it. If you look closely at the lower center, you can see the strike team there that a previous helicopter had dropped off. It didn't get more than a few acres, but I again streamed it and people enjoyed watching it. So another thing you can do with this is, like you would expect, is messaging. Because it's a standard TCP/IP network, any mail server and client can run on it. You could use like a Thunderbird client. There are web clients, Roundcube. It kind of looks like Gmail, only better. Um, if you remember the BBSs, there's one that we've used. And Windlink, which I'll talk about a little bit more. Windlink was originally for boaters. It was HF communications to stay in touch. But since then, it's been expanded greatly. It can use all of these low-speed HF protocols, automatic link establishment, which is a very, very early linking protocol. The radios are frequency agile and very pricey. And they're not ham radio, they're commercial radios. APRS can carry Windlink messages, packet radio, D-Star, all of the PACTOR radios, and VARA FM and VARA HF. But in the last couple of years, they've added support for AREDN networking, which I've already mentioned is much faster, but there's no digipeating required because the network knows how to route to the destination. It's easier to move traffic and faster. And if you've never used Windlink, they have a large set of standardized messaging templates for like incident command system, USGS, I'm trying to think, EOCs, stuff like that. This is the Windlink architecture. This is an old graphic. I've tweaked it to bring it current. And you can see where the ham radio networking goes there. It's moving stuff locally. So here's a screenshot of Windlink. It's mine. It looks pretty much like regular old email. The difference is, depending on what RF links you have in your area will determine how you send it. And there's a little bit of a learning curve, especially if you have HF, VARA FM, and mesh networking coming into your computer like I do. So anyway, this is the shot that shows moving traffic. This one happens to be a network server. If it was packet, it would show packet, etc. But what I wanted to point out is down here, this is a 22 kbyte message I moved over the mesh network, and the time elapsed was 3 seconds to move the network up to move the entire traffic up to this post office up at the top. And total link time was from 44 seconds past the hour to 54 seconds. So 10 minutes total, not too shabby. So if you remember in the old days of dial-up BBSs, they were all DOS or maybe even before that CP/M, and they were kind of do-it-all. They were all in one, calendar, chat rooms, email, stuff like that. Well, if you spin forward 40 years, they've been webified, and this is what you see for Citadel. It's got all your stuff on the left you can do. You can set it up for email, and this runs nicely on a Raspberry Pi. If you had some group that was doing a lot of collaboration, working closely together all the time, you might want to spin one of these up for that group. Because it's just an IP network, you can hook two analog repeaters together with some of this external gear from, I don't know, JPS Communications or Skymira. It provides an Ethernet link and transfers all of the repeater signals back and forth, the audio back and forth. Carrier operated relay goes from one to the other. Push to talk goes some aux channels. These can be had reasonably affordably on eBay. Other things you can throw up on the network, your weather station. This is mine. This is from April 7th and looks fairly boring. I mean, you can see everything you want. And this is out on I'm running this on a Raspberry Pi with software called WeWX. If you've ever thought about putting up a website with your weather station on it, I would highly recommend WeWX. It runs on pretty much any operating system, and it supports every weather instrument you ever heard of and a lot more you never have. And it's highly configurable. This is the vanilla user interface. Some people go crazy, like this guy. This is not on the mesh network, but I think he has too much time on his hands. We've put up a Scrabble server and played Scrabble. You know, it's not all about emergency communications. BZ Flag is a nice tank game. You can spend some time shooting up each other's tanks. And once in a while, after the weekly net, we play a few games of poker, Texas Hold'em. So Eric KG6WXC wrote a network crawler, network mapping program. It's open source, available for anybody, and there are probably by now 2 or 3 dozen instances of it running on ham networks around the world. And I've taken a few screenshots. This is just north of Bellingham, Whatcom County, Salem, Oregon. On the map, nodes that are orange are 5 gigahertz. Purple is 2 gig. Pink is, I think that's 900. And the ones that are gray have no RF links. They're strictly routing. So you've got a nice little network going there. Hawaii came up online less than a year ago. Considering every island is a mountain, they're doing relatively well. Currently, all of their inter-island links are internet tunnels, but they are actively working at replacing those with RF links. Here's Yakima, Washington. Chris has done a good job of deploying this. And I saw recently these orange ones on mountaintops. He's deployed some pan tilt zoom cameras. And he's gotten some great shots. Here's Southern Ohio. This is used a lot during the Dayton Ham Fest. This one's kind of near and dear to my heart. San Francisco Wireless Emergency Mesh is SFWEM. I gave a presentation on mesh networking at PacificCon in the East Bay in October of 2019. At that point in time, they had 2 or 3 disconnected nodes, but there was a lot of interest in it. And to be honest, I kind of got mugged out in the hallway after the presentation. So within the next year, they had most of this online. Didn't hurt that San Francisco is a fairly forward-looking city, and they gave them access to, I don't know, pretty much every city radio tower there is, and they're working at pushing it east over into the East Bay and then beyond. They'll have it up into Walnut Creek, and let me see where else. Oh, down here in the lower right, there's a mountain here in the East Bay called Mount Diablo, and they have the gear for that, and they'll be pushing it down the network down to Pleasanton and Livermore. Here's the big daddy, Southern California. We kind of had a head start because a couple of the developers, the AREDN developers, live down in Orange County and San Diego, so they got a head start. In the area you see there, about 250 miles north end to south end, as Patrick mentioned, about 400 nodes, a good mixture of all of them, but you know, let's zoom in on yours. Here's the Santa Clarita Valley. The very northerly one here is K6BFG's QTH. The one on Route 5, it's right off of the 126 is his work location. And down here, just to the west of the 5, and I think it's Pico Canyon, is Tony, K6AMD. They've come up on the air in the last year. This node here, the high-level node they're connected to, due to politics, all I can say is it's in the vicinity of Magic Mountain, and it's linked into the rest of the network. And it does a pretty good job of covering the Santa Clarita Valley. This is the blue coverage map. I tried to get the roads to show through, but you get the idea. There's the tower in the lower right-hand corner. Doesn't do such a good job in Newhall. There's a tiny hill shading it just to the, I don't know, west-northwest, and that's why Newhall doesn't have good coverage. But does pretty well. These things, with a decent dish antenna, you could link up to this 20 to 30 miles away and still get good throughput. So what's out there for equipment? This is the hardware that's currently supported. For the 4 amateur bands I mentioned, they're designed for outdoor use. That is, they're weatherproof, they're power over Ethernet. You don't have to run a separate Ethernet and power cable up. They've gotten really sophisticated. 2 software-defined transceivers in every device. They're for MIMO. Typically, dual channel MIMO is vertical polarization and horizontal polarization. And they send part of the data stream over each transceiver and they recombine them at the end. If you've got multipath, remember how multipath used to make your TV signal flutter? No problem. They'll take the data coming across the multipath and combine it for better throughput. Most of them have built-in gain antennas. You have a gain antenna polarized vertically and another one polarized horizontally. The MIMO and the 802.11n is the magic sauce that makes the two transceivers work really well together. A couple caveats here. Be careful buying older equipment for a couple reasons. As OpenWRT grows, the AREDN code based on it grows, and some of the older devices only have 32 megs of RAM, and it's getting very tight to get the firmware in there. And if OpenWRT drops support for a device, there won't be any future versions of AREDN for that device. In fact, all the new stuff you buy is 64 megabytes or larger. And don't buy if they're not MIMO. You get half the throughput for a given signal to noise ratio, and the MIMO stuff is not expensive. Also, they don't mix well. If you're trying to combine, send 2 data streams to the other end and you only got 1 receiver, you get half the throughput. And if you're concerned, the AREDN website at ardenmesh.org has flagged, they have a whole list of compatible hardware, and they've flagged the ones that they don't approve for a new purchase. So here's old school. This is what people did 8 or 9 years ago. Linksys WRT54G, which only has 4 megs or 8 megs of RAM, firmware. Not PoE, and in spite of having 2 antenna jacks in the back, it was not MIMO. You had to wire all that stuff up and hack on it. And remember I said the devices are typically around 600 milliwatts? His Linksys 60 milliwatts, so 10 dB handicap right there. They're Ubiquiti Nano Stations. They're about, I don't know, 8 or 10 inches tall. Not expensive at all. They run very, very well. 11 to 13 dBi gain, about a 45-degree beam width vertically and horizontally. They look identical, the M2 for 2 gigs and the M5 for 5 gigs. I'm not recommending the M5 anymore. It's a fine piece of equipment, and I'll talk about why I'm not recommending it anymore for new purchase. A lot of people buy these Ubiquiti Power Beam for 5 gigahertz in the 300 millimeter, 400 millimeter, and the 620 scare your neighbor diameter dish, super high gain. The microticks have become very popular in the last couple years. LHG means a large head grid, and I got an XL and an HP XL. They're very popular because they're quite a bit lighter. If you're going to do a mobile installation, they're easy to put up on a small mast on a tripod. Additionally, because they have a grid in the back, they have less wind resistance than the solid dish of the Ubiquiti dishes. TP-Link isn't nearly as popular as it should be. Really good gear. It's been 64 megabytes forever. CPE 210 and 220 for 2.4 gigs. I think I have a 230 now. I have an old CPE 210 version 1 that's still running. they look like the Nano Stations. I'm not recommending the 5 gig for purchase now, and for the same reason I'll explain. The CPE 610 dish here on the right is 5.8 gig. It's been discontinued and replaced with the 710, which I don't believe is supported by AREDN yet, but it works fine. And if you get it for cheap on eBay, I'd say go for it. So this is obviously not a weatherproofed. You can get going with one of these nodes, but the AREDN software uses all of the 10.0.0.0 network, and you can't change the addresses, so it doesn't play well with your home network or the network in your ham shack. This little router here, when loaded with AREDN software, fixes all that. You can see it here. The port 5 here is your outdoor Ethernet cable going to your node on your mast, and they talk AREDN together. It's called DTD, device to device, and they pass routing information. Then port 1 gets connected to your home network, and anything connected to ports 2, 3, and 4 has access to both the ham radio network and the internet. Highly recommended. It has a bunch of other features too. This is pretty much the second thing anybody buys who gets into ham radio networking, and they buy it almost immediately after they get their first one. So anyway, a few pictures of home installations. Here's a couple Nano Stations up on a second floor gutter. Why does he have two? There's a 2 gig and a 5 gig pointing at the hill a couple miles away that has a 2 gig and a 5 gig access point. If the hill loses one of those two access points, he's still on the air. We try and do this at every EMS and EOC and hospital that has access to multiple channels for redundancy. This is KM6 PTEs. He's got both a Nano Station and a Microtech grid. I didn't mention it, but the Nano Stations have 2 Ethernet ports. You can run your PoE and Ethernet up into one, back out of the other one, and power a second node. That's why they're really, really popular for portable installations. When one of these is running like hooked to the mesh network, and the other's running the vanilla Ubiquiti software as a part 15 access point, and everybody's phones can get linked to it, and they can make phone calls across the mesh network with their vanilla smartphone. So anyway, here's another one. If you're in an HOA restricted area where the only thing you can put up is satellite dishes, here's the cure. This is a Microtech Light Dish Feed 5 with an $8 universal adapter fed to a Hughes DirecTV satellite dish. You put one of these up, and chances are pretty good your neighbors will never notice that it's not pointed at a synchronous satellite. So a lot of the stuff that I've shown, the equipment previously, might not be suitable for a high-level site. It would be kind of like using a Baofeng handy talkie as a receiver at a repeater site, just not appropriate. Here's a sample of some of the equipment we use at repeater sites. The breadbox looking thing is the sector antenna. They call it a sector antenna because it illuminates a sector of the compass. Typically they're 120 degree in both vertical and horizontal polarizations. If you look closely in the back of it, you can see the little SMA connector and jumper connecting to the radio, and there's another one on the other side. The smaller box is a Rocket M5 by Ubiquiti. So this is a 5 gigahertz sector antenna. So we use a lot of those. So here's a small site in North Orange County. He's got 2 gig, 3 gig, and 5 gig sectors pointing south with the hill on the north side of Orange County someplace that shall remain nameless. Painted green for camouflage, I guess. Those look wider than the regular sector antennas because he's got shielding around them. The shielding is larger, and he's painted that. He's got 2 cameras, a pan tilt zoom at the top and a bullet camera here. The bullet camera is actually looking back at his battery and solar panel installation. He doesn't have a weather station there, but he strapped a clock type thermometer to the onto the solar panels, and he can see it through this camera. Here's a medium size installation. This is the one I take care of. On the tower, on the tippy top is the Omni for a 2 meter repeater. On the left, upper left, is a 3 gigahertz local backbone. It connects 2 other sites together. Let's see, upper right is a part 15 user access. It's not part of the ham radio network. The small dish is for a test network. It's hardly ever used. Lower left is the 2 gigahertz ham radio access point, AREDN code on that one, and this one. And this one lower down, that is the 5 gigahertz user access point for the AREDN ham radio network. The big dish is the link pointing pointing west to another county backbone site. There are a whole bunch of Ethernet cables run underground to the container. Most of the stuff on the left is county gear, except for the small pan tilt zoom. That's ours. And then there's a 4-pole for a UHF repeater and a 420 megahertz linking. You can't see it, but there are stairs behind here going up the hill and some buried Ethernet cables. And there's another larger ham radio container up there. And there's another dish, 3 gigahertz dish, pointing west at Verdugo Peak. And it talks to this one here. That looks kind of impressive, but only part of it is mesh networking. And by the way, this is after a really bad windstorm, and the HF remote antenna has since been fixed. The only mesh gear up here are 1, 2, 3 sector antennas, 2 gigs pointing west into the San Fernando Valley, 5 gigs pointing west, and one of them is pointing south, I think. And like I said, this 3 gig antenna links to Chatsworth Peak, which we just looked at. And over here on the telephone pole, one of these links continues our backbone west to Mount Wilson. And here's what you'd seriously call a large site. This is a commercial installation on a hill called Pleasants Peak in Orange County, East Orange County. It's a commercial tower, but the owner is ham radio friendly, and one of the AREDN developers lives not very far away. So over the last half decade or so, he's put all the stuff pointed out with yellow arrows on there for ham radio networking. What you can't see below this picture is a set of dishes pointing at 4 points of the compass, linking all of the portions of the backbone together. So there's some serious investment in some of these. So how do you tell if one of your if you can see a given site? Of course, I've already told you, if you can see Loop Canyon, then chances are good you can use it. But if you want to mess around with it, heywhatsthat.com is pretty easy to use. You put in your latitude, longitude, and elevation of the antenna, and it'll tell you what's a line of sight from there. airlink.ui.com is Ubiquity's site. It's fairly easy to learn. radiofresnel.com is a little more complex, and Radio Mobile comes with a 200-page manual, but is very comprehensive. So let's talk about the bands. This is, all of these channels are actually ham radio channels. Problem is we share 1 through 6 with public Wi-Fi, and as you'd expect, it's quite noisy. When I first got on with the AREDN code, it didn't yet support the part 97 channels here, and I was trying to work a ham 2.5 miles away. We were using channel 1, and there were 45 access points visible to mine between him and me. When we got the beta code and we moved down to channel -2, poof, it was him and me, and link qualities went from 75% to above 95%. channel 0 is flagged as not available for use. I believe that's because all of the wireless code really objects to a channel of 0. Divide by 0, I don't know, something. We don't generally recommend -1 because there's a lot of splatter, the part 15 bands. So while it was nice to get down into a ham radio channel only, the problem with this band is there's only one channel, and you can't spread your traffic out. So here's 3 gigahertz, which is all ham, or it was up until a few months ago. The FCC, in their infinite wisdom, has decided to give it to the wireless carriers for expansion of their 5G networks. That's not 5 gigahertz, that's the 5th generation wireless. Sometime early next year, they're going to take away the channels indicated in red, and all hams using those have to move down into the lower channels, 76 through 89. And at some point in the future, they may take it away from us. I got lucky. All of my 3 gig stuff is on 3440. But when they take it away, I'll have to put 5 gig gear up and throw away a couple $1,000s worth of 3 gig gear. So here's the 5 gig band. Those are all ham radio channels, but they're shared. The orange ones are currently ham radio only, but that's only because the primary occupant never occupied it. We've been secondarying that band to the Department of Transportation for, oh, I don't know, 10 years or so, maybe a little longer. FCC gave those channels to them to try and develop a vehicle to vehicle communications protocol. Well, they've been futzing around, and FCC finally got tired of it and yanked their allocation, although that's still in the courts. What the FCC is proposing to do is let the unlicensed users expand into there. We will still have use of those channels with ham radio regulations. It's just that the noise level may gradually come up, which is why I was saying if you're going to put something on a hilltop and there's other wireless stuff up there, probably buy something with more gain than you think you need to kind of future-proof the installation. You don't want to put a Nano Station up there with 13 dB gain and wind up needing another 5 to 6 dB gain in 2 or 3 years. So where to get ham radio network information? ardenmesh.org. Software downloads there, production and nightly builds. They typically now are doing a production release once a year, or maybe twice a year, but in between they're adding features and taking out bug fixes and adding new equipment. So a lot of us test the nightly builds. Every nightly build is a pretty small incremental change, so they're pretty safe and it's easy to revert. A bunch of how-tos there, FAQs, frequently asked questions. Steve, AB7PA, took it upon himself about 1.5 years ago to gather up all the documentation and put it in a wiki. And it's excellent, easily searchable, and well categorized. The AREDN forums have about 3,400 members. There's various topics. There are also regional forums for various states and countries, and then in the more populous states, they're broken down into counties and in some case cities. If you're on Facebook, the Facebook group is very active. There's over 1,400 members there. There are 6 or 8 other mesh networking groups on Facebook. Yakima has one. Where's the other one? Utah has one, stuff like that. You can look at videos about ham radio networking on YouTube. The little asterisk there is just to kind of beware. The older stuff is based on the predecessor to AREDN, the broadband hamnet. If you found a video older than about, I don't know, 18 to 24 months, I'd say skip it. I have a beginner's guide PDF that covers the basics of this. And also I have a PDF-ized version of this presentation that I can pass out. Any questions or demo? I can demo. let me do one real quick thing here. While I've got your undivided semi-attention. Let's go over here. You know, those, don't give me some grief here. Oh, my internet didn't go out. Yeah, there we go. Okay, all those cameras we have up there, there's no point in watching a video stream of grass grow. If nothing's going on, there's no point in watching the video stream. So what we do is we take a screenshot every 5 minutes and post it on a web page on various servers on the hilltops. But this side aggregates all of them. It's getting kind of dark, but you can kind of see. I don't know why Glenn wants a picture of his tower, but okay. There's a inside of one of our buildings, and there's the outside. One night the wind blew the door open, and I could see the light shining out. And oh crap, we got to go up and close that. And you can see it's starting to get dark. Let me see. Oh, no, that's not it. Hang on. I got to get my. I'll show you a just what a node looks like. Not that it's real exciting. It's a web page. It's just a place to manage the stuff. You don't do anything here, but you can see there are 400 nodes visible on the Southern California network. And if you connect up to the Loop Canyon mesh node, you can get to anything on this. Let me show you real quick the mesh status page. You'll see two columns. On the left are nodes that are more than one hop away. On the right are local neighbors. They could be either RF or tunneled or something. Let's see. Well, my stuff, blah, blah, blah. Here's the Nano Station at the Simi Valley PD, other stuff like that. I think I've beaten that to death. Anybody have any questions? I'll just stop sharing here.
Or can I get an explanation on one thing?
If you buy one of these things and throw it up, go for it.
When you're speaking of tunneling, what are you talking about?
If you have one of those little, suppose you put a node up and there's no RF connections, you're out of luck. You're sitting there standalone. Well, you can set up a tunnel between that node as a tunnel client and somebody else's node as a tunnel server, and you get your network, ham network connection over the network via his node. A lot of guys have to start out that way.
Is that over the internet or the RF net?
No, if you have no RF, you go out over the internet.
Understand.
AREDN strongly cautions against using tunnels for any part of your network that's emergency critical, because you know what goes down in an emergency, the internet. So they recommend getting RF everywhere you can to all your emergency services. The other thing the internet is handy for, and we've used it, is tunneling around RF outages until we can get them up just to maintain the network.
Now, it sounds like you have several ways to get into your network as a repeater on a mountain, analog FM in with a gigahertz radio. Is that one way to get voice, or?
No, it's digital voice. It's carried like we're talking on digital voice now over the internet.
Mm-hmm.
You would talk digital voice over the ham radio network. It's an IP network. It is not analog. It's not FM. It's just packets. It transports it end to end.
So how do you get into the network? Via your computer, or?
Once you put the node up, it connects to the network if it sees a node on the hill. Then you connect your computer to that node, your home node.
Okay, so as a newbie, how do I explore this new, or not new, but how do I explore your network?
Well, you have to get on it first.
So you can't. So I can't just get on it via the web and look at your your camera. It's got to be
No.
through your network.
That's correct, because we kind of discourage internet access onto the ham radio network because FCC has some really old school regulations about encryption, and pretty much any website you go to now is HTTPS, which is technically encryption. Go ahead.
How deep do we need to get into our wallet to start into this?
Yeah.
Oh, price of 3 Baofeng handy talkies.
So
That
you're saying,
And up. No, seriously, a node good enough to get. I hate to have you buy low end gear and be dissatisfied with the
Understand.
performance, but the little dishes are $75, and you probably pay more for a chunk of outdoor Ethernet cable, weatherproof cable, to get it down into your shack. And really, you need one of those little AREDN modems down in your shack to really make it all come together. That's it.
No Raspberry Pi or anything, or is that part of it?
If you want to run a web server or something, yeah, but that's optional.
I see.
Yeah, the network is just a network. Any of the stuff you want on it, you have to hang off of it. Web servers, weather stations. I mean, those are all optional.
So
Of course, it's pretty boring without them.
Parts lists are listed on ardenmesh.org. Is that?
Yes. And if you drop me an email, I'll send you my little getting started PDF. orv.beach@gmail.com. Oh, hi, kitty. What's the kitty's name, Eric?
His name is Buddy. He's a lynx hybrid.
Oh, cute.
He's a
Sorry.
indoor-outdoor cat.
Nice.
he's a strata, no, actually he's a P-base, isn't he?
Orv, is there a membership required to use your mesh system?
No, not exactly. But you know how a new ham can get on with if he's lucky, with a Baofeng handy talkie and get started, and he talks to a repeater. Well, if you look at a repeater site, it's not cheap to run.
Right.
I mean, it's one of those and up prices. Well, if you want to support your local network, I would encourage you to be generous if something needs to be improved on the network. That's all I would say. Because, the sector antenna plus rocket I'm talking about, that's $275. You put, say, 2 of them or 3 of them at different points of the compass. Well, you're adding up. Plus, it's an Ethernet switch to hook into them. And oh, by the way, you need a battery backup, UPS. It adds up. And a few people do support them themselves. Out here in Ventura County, we started a 501c3 specifically for the FM repeaters that group runs, but they also manage the network out in Ventura County. And people have been very generous. It's easier to get donations if you're a 501c3, but it helps. LAMcom.org supports communications in LA County, and they've gathered some money for the mesh network there. We do it mostly as needed on donations. Right now, you're lucky. Santa Clarita Valley is up and running.
And they on all 3 operating systems, Linux, Mac, and Windows for your data?
They're all Ethernet, right? You can plug in a cable. The question is, if you're going to run an application over the network, is there a client for that application for your operating system? 99% of the time, they're yes. Hey, let me share it again if I can. I want to show you something.
My wallet is beginning to get scared.
Oh, it's not. Just ignore the and up.
The problem is I don't buy junk.
This is all good stuff. Let me see here. You can see my screen, right?
Yes.
Yes.
Which visit was this? Yeah, here's the tower we put the node on top of. You see that? See the picture?
Yes. And which peak is that one?
I'm not allowed to say, but it's Loop Canyon.
Okay. I directly in its shadow. I can look right up at it.
So here's the three guys working at the top of the tower. And where is it?
Just curious, why can't you say where these are? I'm new to the whole thing.
Because we're a guest in there.
The problem with a lot of repeater owners and things like that is once you're a guest there, when somebody else wants to be a guest, you get too many people asking.
Yeah.
Oh,
So
okay.
this is looking northwest, and you can see the sector antenna there. That little hump right below it. That's why we can't cover Newhall very well.
Yep.
Boy, I
Oh,
know
by the
where
way-
I know where I'm looking right there too.
Yeah.
Yeah. Just as a little by the by, we may end up putting another dish up there pointing to a site, communication site in Gorman. There's line of sight.
Marvelous.
And from Gorman, we have line of sight to a communications tower northeast of Bakersfield. So we may be
Perfect.
extending the network out there.
That's
So-
a beast of a hike up to there.
Yeah.
Or
Did I stop
realistically
sharing? I did.
speaking, for the average idiot, if you want to get something going in here, you want to get decent equipment. I don't own a lot of junk. I don't have a lot of $5,000 radios. You're talking $500 to get started. You're talking about, what are you talking?
Small
To do
dish,
something reasonable.
small dish, $100. The little modem is, I don't know, I think it's gone up to 55 or $60. And then whatever length of outdoor cable you need to run. That's typically more than 50 cents a foot, but it's not horrible.
Yeah,
Okay.
that's not that bad.
No, not
No.
at all. I've done worse than that.
Yeah, oh yeah. And of course you keep adding a Raspberry Pi here and a webcam there, and oh, and you need the VoIP phone, that's $36, and but it's not like buying an HF transceiver, trust me.
So you're saying by the time you get the goodies, you're going to spend $500 probably to do what you wanted, reasonable fashion.
Over the course of a couple years, maybe, yeah.
Okay.
But Marty,
I'm the guy that's probably going to pop the money down and just say, let's put it up.
But you have to have line of sight, no trees, no
I
houses.
understand.
Absolutely.
I can see Oak
Although-
Mountain from my house. I'm not sure what else I can need to see from there.
Well, that's not Oat Mountain. It's on the other side. It's
I
south
can
of Magic
see-
Mountain.
I can see the area, so I can't tell. I'd have to kind of really get a good look and get a little bit higher and see what I could do. At
Use
the point
that
and find out.
That website, heywhatsthat.com. It's
Oh,
pretty easy to use, and you can model it for your own antenna height. What was I going to say?
I can
Well,
also see
anyway.
that one other tower that you were talking about reasonably well.
Good. If you like messing around with computers and you like ham radio, this is the perfect combination of it. I'm on a Mattermost server right now, chatting with 3 or 4 other hams on the mesh network, spread across Southern California. My internet access has been up and down, as Patrick knows, but I kept talking to those guys because I didn't need the internet for it.
I have a question. All this network is in parallel to the internet, like all the access point that we saw. For example, you mentioned DHCP and all of that. That's inside my shack, but someone need to manage the IP network on that mesh network. Someone need to manage the IP. It like maybe the one, if I compare that to the internet. DNS record, for example, it's external. It's internal.
That's why AREDN designed this to be fairly easy to deploy. It's got its built-in DNS server and DHCP server, and they use an algorithm to define a unique set of IP addresses per node based on the MAC address. So in other words, you put one in your shack and your shack and your shack, they will all have different IP addresses. They won't conflict.
Based on Mac.
Yeah, and in order to run, unless you want two different computers in your ham shack, one on the mesh network, one on the internet, get the little HAP MikroTik. It will combine them access, and it firewalls them off together, so you don't have to worry about security. It's good stuff.
And again, this is all on ardenmesh.org.
Yes.
Okay.
I will be honest, there are other ham radio protocols. You may have heard of ham WAN. It's not popular in this area. They have some in Ohio and Wisconsin or something. That is pure TCP/IP. They write up their own routing tables. They use BGP. And that's really beyond the scope of the average ham who needs to throw one of these up at a fire camp or something, point it and go.
Yeah, I'm using APRS from time to time, and even I keep an eye on the, I'm following this the group, the new packet radio also.
Yes, yes. The Hawaiians are talking about using that between islands. He's talking about NPR, the new packet radio. It's a 420 or 430 kilohertz simplex radio that will transfer TCP/IP or Ethernet actually end to end for, was it a couple hundred kilobits per second, something like that?
Up to 500.
Up to 500, and a much longer haul. Obviously, you're not going to pass a ton of traffic there, but for linking emergency traffic on distances you might not be able to get with this. However, our longest production link down here between mountains is 45 miles. So we do pretty good with high gain dishes. So if you get one of these up, you can join our weekly TeamTalk net, you know.
And when is that?
Wednesday nights at 8 o'clock.
All right. That's cool.
If anybody wants the documents, get my email address from Patrick and I'll send them along.
Okay, well, I'm going to be definitely sending you an email and asking for that PDF to how to get started, because you've piqued a curiosity that I hadn't had before because I didn't know anything about mesh systems.
It's a different kind of ham radio.
I just love playing with antennas and putting them up, so it's fun.
It's fun to put these up. There's no tweaking of frequency or anything. You point it, and oh, by the way, if you've got a high gain dish, the way you get the high gain is a very narrow beam width, right? So they can be tricky to aim.
Mm-hmm.
Well, there's aiming software in AREDN. You can either look at it visually or listen to it as you turn the dish up and down. So it makes it a lot easier. I just looked, Justin lives in very north end, and he's about 10 to 12 miles away from the access point, and he's got a really good signal, but he's using a small dish. I'm hesitant to recommend one of those low-end Nano Stations. So one of the dinky little dishes should just give you a stomp crunch signal good enough for high, well, not high res video, but solid video if you need it.
Yeah, Orv, I'm right near Sand Canyon and the 14 freeway. I look up the mountain and there's Loop Canyon. So I mean, it's really easy. I could probably stick just a piece of wire up there and.
Well, remember, it only has a limited look down angle. You may be shadowed.
Okay. I'm not directly below. I'm probably 20 to 30 degrees below its horizon.
Okay. In that heywhatsthat.com, after you do yours, do Loop Canyon and see if it can see you.
Okay.
And set the antenna height at 100 feet because that's how far it's up. And by the way, it's a 120-degree sector antenna, and it's pointing towards like the 5 and the 126. You'll be off the side a few dB down, but you're so close it should be okay.
Guess where I'm at?
I give up. Where are you at?
5 and the 126. I'm right there.
Oh yeah.
Okay.
You should have no problem.
Mm-hmm.
So guys, if you have any problems or questions, if you have any questions on any documentation I send, please give me feedback. I'm always looking for feedback.
Perfect.
Typos, questions, whatever.
And with the recording that we've done of this presentation, I'm sure everyone's going to be going back through and listening again and trying to pick up more little tidbits that went over the top the first time. And so I'm sure that you've sparked some interest. So thank you, Orv.
Oh, you're welcome. It's fun stuff.
Yeah, thank you.
Hey,
Thank you so much. I really
thanks for hanging
appreciate
in
you
there,
coming
guys.
up.
One
Thank
quick
you very
question.
much.
You
One quick
bet.
question. What's the elevation of Loop Canyon? Because I'm near where Patrick is, and I'm at about 1,600 feet elevation.
It's probably about 3,400 feet.
Yeah, that sounds about right. It's
It-
just past Fire Camp 9.
If
Oh,
you
okay.
see Camp 9, it's just to the right. It's just a
Top
little
of the
bit to
beast.
west.
Top of the beast.
Yeah.
I
Just
think
look
if I
down
stand on
your
my roof, I
street,
can do that.
Jerry. If you look
What?
down your street, Jerry, you're looking right at it.
Got it. Okay.
So,
Also, if you can't hit it, but you can hit Justin or Tony, you can relay through them too.
okay. So that's marvelous.
All right.
All right. Well, thank you,
Really
Orv.
appreciate you making the venture
Yeah,
out
thank
here.
you.
Thank you.
Oh yeah, it was a
Thank
rough
you.
drive.
Great presentation.
Okay, I'm out of here, guys. See ya.
You bet. Thank you,
Join
Orv.
your network. Thank you.
So much.
Bye bye.
Thanks a lot.